Hello all, today we are solving LeetCode problem number 3510, minimum pair removal to sort array part 2. So this is very much similar to the part 1 which we solved yesterday, but the only difference is about the constraint. So we have the numbers ranging till 10 power 5, and uh, and the numbers can be from 10 minus 10 power 9 to positive 10 power 9. So because of this, we cannot follow the same approach which we did yesterday to solve this problem, because that will be consuming so much huge time, which will result in a time limit exceeded issue. So we have to follow the other methods to come up with a solution. So because of that, this problem is very hard. With that, I will before getting into the explanation of the solution and the approach for this, let me read through the problem. So we are given an array called nums, and you can perform the following operation n number of times. So we can select an adjacent pair, which means you have I and I plus 1, or I minus 1 and I. So these two are the adjacent pairs with minimum sum in the nums, right? And replace the pair with the sum. So you can do this n number of times in such a way that you have to get the non-decreasing array, because you may be given an array of 10, 10, 2 and 3, or it can be 4, better, yeah, 4, 2 and 3. So now you have to make this array to a sorted one by performing these and these two operations. So based on which this will be converted to 5, and you have 4 and 5, which is sorted, and the number of operation consumed here is 1. So you have to return the minimum number of operation to convert this array into non-decreasing, which is an ascending order of the elements within the array. So with this, let us go through the first example, and then we will come up with a solution. So in the first example, you can see given the array as 5, 2, 3, 1, and the explanation given here is the pair 3, 1, which is this particular pair, sum is 4, which is the minimum among all the pairs sum formed, and we remove these two elements. Instead, we replace this with 5, 2 and 4, and again this is not sorted completely, and hence because of that, again we will be choosing these two because this has the minimum sum as 6, and because of that you have 5 and 6. This will be getting reduced to 6. These two elements will be removed. In fact, the pair will be removed and replaced by its sum, and now it is ordered, and the operations is 1 here and one more operation here, so which results in output 2. So how do we solve this? We have to follow the simulation only, because that is what will take less time to perform all the operations. So by simulation, what exactly I mean? So by simulation, here we found the minimum among all the adjacent numbers sum, right? So find min sum among nums first, and with its index. So here we can say that at index 0, 1, 2, at index 2 we have the pairs 2 and what was it, 2 and 4, no, 3 and 1. We had 3 and 1. So this is two it has two index actually, which is 2 and 3. So you have to reduce this to index 2 having the sum, which is 4, and then update in the array. So this is how you have to repeat this conditions n number of times until you get the array as sorted and return the number of times you perform the operation. So for this one we will be using heap to get minimum value, minimum sum of pairs among all pairs. And to reduce and track down the index, we use two arrays, which is prev and next. So this previous has the example at you are at ith position, and this at ith position this stores the previous index, which is I minus 1, right? So if example at index I, it stores previous of I will be this, let this I be 3, so in this case previous of I will be 2, and similarly next of I will be 4. So at a point this looks like a doubly linked list, right? So we will be using this to track down the indexes for reducing the index and replacing with the sum value, and we will be iterating by finding the number of number of in pairs which form the which is not order, the number of unordered pairs. So we will be iterating that much amount of time to form the sorted list, right? So with all this saying, let me explain running through the first example with following these simulations. So the first example here is nums equal to 5, 2, 3, 1. So we will have prev as prev and next we have 0, 1, 2, 3, right? So 0, there is no other index left, so this will be minus 1, and 0, 1, 2, and this will be 1, 2, 3, and since there is no index 4, you have to replace that with -1, right? So how we will be using this? So we for merging the pairs. So if I want to represent this algorithmically or in programming language way, so for merging you have to update next of let the pairs be L comma R, right? So the index be L comma R. So next of L should be equal to next of right, meaning we can have it as L as 1 and 2. So now if we merge, 0 will be there and 3 will be there. This should become 1, right? Let this be L, where if we merge L and R, we have to merge R into L. So in that case this link should be formed, right? So because of that we have to make sure that this is left and this is right. So next of left, which is 2, we have to mark that to next of right, which is 3. So we have done that. And if next of right is not equal to 1, which means if some element exists which is 3, 3 is here, so in that case you have to update the previous. So a prev of next of r should be equal to L. So you point out this to L. So this creates something kind of the doubly linked list, right? So which will be of example, we can have this 0 as left and the link as right, left, right, and the 3 as right. So this is neighbor 1, this is neighbor left, neighbor right, and these two are the pairs which got reduced to left and this to right. Right, so this will be replaced by the sum. So this is the expression here, and now we have to append the sum along with the index into the heap. So we declare the heap, let it be q. Okay, so we will be iterating through it, through the nums, and we have to track down how many unordered pairs are there. So if nums of I, we iterate for loop for I in range till n, you iterate till n, let me write it like it, iterate till n, right? Nums of I minus 1 is greater than nums of I, you track down in unordered plus or by 1, right? So by this you get the number of unordered pairs available, and then you have to calculate the sum of two adjacent pairs and append them into the heap. So based on the first iteration of the numbers 5, 2, 3, 1, you have calculated the previous index and the next index, next array, to track down and reduce, to merge that into the single index, right? And now this is the heap operation. So based on this, 5, 2 is a pair, 7, the sum is 7, and 2, 3 is 5, and 3, 1 is 4. So the index here is 0, and this is not 0, right? This is 1. You have to reduce right to left, so this should be 1, and then 5, 2 will be 2, and 3, 1 will be 3. So you store this in the tuples format, and then you push them into the heap q, which looks like something like this. So it's a min heap, so you will have the minimum element at the top, right? So 4, 3, and 5, 2, and 7, 1. So also you have based on this is greater and this is greater, so 1 here and 1 here, and unordered is equal to 2, right? So you have the previous and next array, and you track down how many unordered pairs exist, and now you track you have the possible sum and its pairs, its index as a pair of in the form in the tuple. You have that in the heap. So in the iteration you can pop the first first element, which will be the minimum value, right? So now you have to replace that with the sum. So for that you iterate while till unordered not equal to 0. So you iterate till this condition, you pop the first element, so you have 4 and 3, so which means you have total sum will be 4 and the r will be 3, right? Now you have to calculate the left one, because you have a right index, so you have to calculate the left index, and you have to reduce the right into left. So left will be equal to, this will be prev of right, which will be 2. So you have r as 3, total sum as 4, and left as 2. Right, so now you have to merge right into left. So because of that, nums of 2 will be 4, not 3, right? Because r is 3, it will be getting reduced to 2, so this will be 4. For reducing it, you have, this is the code, this is the logic, not the for one, for this is the logic, right? So you have nums of 2 updated back to 4, and nums of 3 will be none, or this should be no value at all. This is removed, so for that we will be using inf here to show that we are not using this, there is no element here, right? So that we will not be using this particular index value for the processing the or finding the sorted array, right? So now this is the one, and now you have to check the if it is the formed uh, pairs, right? So is it forming an inversion, or is it a unordered one? So now you have to check. So check inversion for 2 and 3, right? So here it does not check, so here it does not form any inversion. So in that case, you reduced unordered, reduced by 1, negative minus or equal to by 1, so it becomes 1 here from 2. So we have to go for one more iteration, right? So now the nums formed here will be 5, 2 and 4. So in the next iteration, again you can see here that this uh, this element here, this is smaller than the right one, right? So because of that, now we have to calculate again the sum, which will be 7 for index position 5, and 2 will be 7 for index position 1, and 2 and 4 will be 6 for index position 2, right? So now you have to push that into the heap, and again in the next iteration, that is now unordered, will be 1, right? So in the next iteration you have to perform this, and now you have the heap updated heap as 6, 2 there, which will be the minimum element among that 6, and this will be 7, 1, right? This tuples will be there, so this will be the minimum element. You pop the value, and r is equal to 2, and total sum equals to 6. Now L will be prev of r, which is nothing but L will be 1. So r2, you got all these things, L is equal to 1. So now you merge, and nums of 1 will be 6, right? And nums of this is 1, right? Yeah, and 2 will be inf, right? And now check for inversion. There is no inversion, so based on this you have to check the previous element. So previous element, which is nums of I minus 1, is if it is not greater, which is lesser than nums of I, you reduce unordered by 1, right? So in that case, the unordered become 0, and as a result of the first operation, where is it? Yeah, so as a result of this first iteration, you have res is incremented by 1, and this operation results will be plus or equal to 1, so which means res is updated to 2 and unordered is 0, so you came out of the loop, and because of that you will return the result as 2. So with all these observations and this from the simulation, we will go ahead and code this up. So for the time complexity for this problem will be big O of n log n, because the heap operation push and pops consumes a log n times big O of log n, and we use for loop and while loop for iterating and performing the heap operation, so which consumes linear time, which is order of big O of n, right? So because of that, it is big O of n log n. And first finding n len of nums, right? And now we have to define we have to track down the previous and the next, because we need to contract the size of the array, right? Meaning the adjacent values, we will be summing it up and reducing that to a value, right? So because of that, we need to have a track of next and the previous to the index. So as discussed, we will have a array for that, so array or list, whatever. So pre is equal to this is n, and next is equal to I plus 1 for I in range of n, right? And here this loop stops, right? So since it is I plus 1, this stops somewhere before n minus 1, so you will have the last index not filled. So because of that, next of last index will be -1, right? So now we have the complete array which tracks all the indexes next value as well as the previous value, and previous we starts with -1 and ends with n minus 1, and here this starts with 1 and ends with -1, right? So now we will define the heap q, and we will have a variable for tracking the ordered order of the array, right? So unordered be 0 first, and now we have to push the elements, find the sum and push the elements into the heap by using heap push, where we will track the the index and the sum as a tuple, and we then push it so that we will get the minimum sum by using the min heap. So for I in range 1 to n, if nums of I minus 1 is greater than nums of I, then RED unordered will be incrementing by 1, and then you push it. So Q and the tuple is nums of I minus 1 plus nums of I, and the index will be I. So now you have the heap ready. So first we traverse through the array and find which are all the how many unordered pairs are there, and then we push the sum basically along with the tracking the index into the heap, so that we will be getting the minimum sum out of it, which we can add them we shrink the two values, we reduce the two adjacent values into the sum, and we then add the sum into the array, so that we will be getting the minimum operations to perform this, right? So now we have to initialize the result value as 0 to track down the number of operations, and while so until we getting this unordered value was 0, we run this operations to calculate number of operations required for this conversion, right? So now total and r be heap pop, right? So now, and this will be previous of r, because we need two indexes, right? So based on which we can access the numbers, and we can get the sum of it, and we can remove that end two index numbers from the index, the array, right? So L is equal to prev of r, and now we have to skip the illegal entry, right? So if in case because based on this operation, sometimes we may result in L equal to L value, sorry, a -1 as a value, or we may land on a value which is already being removed, which is inf, right? So on that case we have to skip that. So it should not be and, it should be r. Then again r nums of r not equal to total minus nums of L. In that case continue, because we have already processed those areas, and we have to jump to the next part, right? So now we have to merge the right and left into left. So next of L will be equal to next of right, and if next of right is not equal to -1, then you have to make sure the prev of next of r is equal to L. Right, and now we have to fix the inversion, which means if we have to check if there is any the unordered pair found in the array. So if we do not found anything, which means that we have this L and R, right? So now based on this updated value, if we find if L nums of left is greater than nums of R, so in that case we have to reduce this unordered, so that we can we will be coming into the condition where the unordered become 0 in some point, and we will come out of the loop. So on that occasion, so this should be fix inversion. So if nums of L is greater than nums of R, in that case unordered minus or equal to decrement by 1. And now you need to track on the you have to work on the left neighbors and right neighbors, right? Because till now we are dealing with only the adjacent pairs, which is from left to right. So now we have to deal with the left neighbors and right neighbors. So left neighbors will be previous of left left adjacent index, and right will be next of right. So now deal with left neighbors. So if left not equal to -1, in that case you have to check the previous inversion and the new inversion which is formed with the total, right? So uh, previous inversion is equal to nums of left that should be greater than nums of L, right? And new inversion formed which will be compared with the total, so nums of left should be greater than total, which is a sum which we popped from the heap, which is the minimum sum, right? So now unordered will be increment based on these two values, based on we get the true, the boolean value here, right? One true or false, which is 1 or 0. So based on that we increment here. So new in minus prev inf. So similarly we have to deal with right neighbors as well. So let me copy this down, change the values, and this should be right should be lesser, right? So and nums of right again should be lesser than total, and this should be right. Yes, and what else? Previous inversion and new inversion. So again we are adding this previous inversion, new inversion minus previous inversion, I'm sorry. So and oops, I forgot to add one more step here, because we need to update, we got the updated index value and the sum value, right? So now we have to push that into by adding the sum. So we have this nums of left and this total. So as per this we have to push that into the heap, push for undergoing the next process, right? Because we found this is not in the order, so we have to track down the index as well as the sum, right? So for the next set of iterations, so in that case he push q, and we have to add the tuple which is nums of left with added with total, and the index will be L here, and here he push, this will be nums of right with total, and this will be right, yeah. So now we have to update the value, right? So we have, because we have removed the two, out of adjacent pairs we have shrink the sum. I mean, we have converted the two pairs into a sum, and in one particular index. So in that case we have to in the original array we have to replace one particular index value as the none value or the inf value, right? So because of that, I think I'm still in the loop, yeah. So because of that, nums of left will become the new total, right? And nums of right will be inf. So you get the new value. So this marked as none or removed, or this is not a value at all. So and now you have to, after performing this operation which consumes one particular operations, right, as per this, so we have to increment by increment by 1 the result. So result plus or equal to 1, and now we can return result. Yes, so let me go ahead and submit this. I'm so sorry about the issue, because that error was caused because of this one, which result in uh, the runtime error, which is index out of range. So we have to change this to total should be greater than nums of right. So yeah, so let us go ahead and submit it, and I checked it was working fine. Yes, and this is an efficient solution. Thank you.